Thank you very much, Joe. I'm really excited to see that so many people are present here. So as Joe said, this is a collaboration between the UK-based DevOps for Everyone and the Nordic-based Cloud Native Nordics. And what we're basically doing is that we're a loose community of people from Denmark, Sweden, Norway, Iceland, and Finland, who are very much passionate about cloud native technologies and in particular the Kubernetes ecosystem. And we're trying to share knowledge via Slack channel where we're having discussions, but also expressing just, hiring interests or how do you use this project or what problems do you encounter? And really just trying to help each other out to be better at what we're doing thanks to cloud native technologies. So today I would like to talk to you about security hardening Kubernetes. First of all, my name is Cristian Klein. I'm both a senior cloud architect at Elastisys, and I'm also a researcher at University. And what I pretty much do is I'm a researcher, teacher, and consultant in cloud computing and information security. And Elastisys is the company behind the compliant Kubernetes open source Kubernetes distribution, which basically packages best of breeds open source projects in order for reducing the compliance burden with various regulations such as the GDPR and HIPAA. It's open source and CNCF certified, and we're providing it both as a managed service, but of course you're also free to download it and to contribute to it since it's open source. And I hope that by the end of this presentation, I would have convinced you that indeed there is a good reason for this project to exist. So today I will talk about, first of all, why is security important? What are the Kubernetes attack vectors? How to security harden each of these attack vectors? And then we'll end up with hopefully plenty of time for question and answers. So let me start with why is security important. Now, since so many people have joined this meeting, I assume that there's no point in me convincing you why security is important. The real question is, how do you convince your boss to allow you to security harden your Kubernetes cluster? And let me pre-package a few arguments for you. So if you're dealing with any kind of personal information, and I assume that quite a few of us are doing that, GDPR Article 25 tells you that you should have data protection by design and by default. And Article 34 tells you that in case there is a data breach due to personal information, you have to communicate that to the data subject and your national regulator as soon as possible. Failure to comply to GDPR means that you can be fined by 4% of your global turnover or 20 million euros, whichever is greater. So I hope that these numbers are kind of convincing you that whatever your salary or the salary of your security team is, it feels like a fraction of what fines could be. Now, I wanted to also show you that, well, this is not just some regulation that is there out there that bureaucrats have invented, but it has some real life consequences. And unfortunately, I would like to draw your attention to an incident that happened last weekend. In Finland, there was a huge psychiatric center, which was, my understanding, quite at the forefront of digitalization. And they have been attacked by ransom back in 2018 and 2019, according to what I understood. And in this weekend, the attackers have decided they're going to basically blackmail the patients of that that psychiatric center and basically threaten them that, okay, either you pay up 500 euros or we're going to release your patient's records, your most intimate details to somebody on the dark net. And yeah, I don't want to get into the whole story. Apparently, the CEO knew about these breaches and has tried to hide it away because of an acquisition that was pending. So I think that we're going to hear about this story quite a lot. And I'm not sure how you feel, but I personally am extremely angry and upset about this incident. It shouldn't have come that far as to be able to, make hostages out of people that are in such dire need of help. But anyway, let's not stay in the complaining side, but rather let's look at this a bit more rationally. What are the risks when it comes to digitalizing your enterprise? And I would say that my characterization from worst to least bad is that attackers may steal money, they may steal data, they may corrupt data. So for example, I don't know, to add themselves some extra cash in their bank account. Data might get lost. or your business might just be disrupted. And then finally, they might be doing some kind of unauthorized operation. So here, for example, it's pretty popular to just find some kind of VMs that are free and then do Bitcoin mining on them, or sending spam, although that is being increasingly difficult since everybody kind of blocks sports 25 nowadays, and so on. So the solution to that is very generically called information security. And I have copy-pasted bits and pieces of its definition from Wikipedia just to go through it a little bit again. So InfoSec is the practice of protecting information by mitigating information risks. It typically involves preventing or at least reducing the probability of unauthorized inappropriate access. And then the next part is, although it may also involve reducing the adverse impact. And then finally, all without hampering organization productivity. So I've highlighted the things that feel to me a little bit to be the most important. So first of all, the focus of InfoSec is mitigating information security risks. The only certainty of making a secure system is to unplug it. And even there, if you are familiar with the Stuxnet attack, it seems like a sufficiently gifted attacker with a sufficiently high budget can even go via air-gapped networks or can use social engineering to penetrate your infrastructure. Then the second one is that InfoSec is not just about preventing breaches, but it's also reducing their adverse impact. So for example, an attacker might be able to gain access to one database, but then they should not be able to laterally move through infrastructure and gather everything they can. And there's also very much focus on doing all of this without hampering organization productivity. So you shouldn't, have to sign off 20 forms in order to do a new deployment of your software, but you should kind of try to find a conscious balance between risk and speed in your organization. So how exactly does this work at a very high level? So first of all, we identify the risks and the potential threats. We evaluate the risks. Then we have to decide on what exactly do we do with these risks. Do we avoid them? For example, we're not going to store any personal information because the risk of doing something wrong is just too high. Or we're going to mitigate them by, for example, protecting this personal information. We can also share it. So this is a way of saying that we're just going to have a third-party processor for personal information, for example, and then it's their risk to take. Or we can just accept them. So for example, it is said that unfortunately, how to deal with GDPR is often a little bit confusing for larger enterprises. And some of them has actually resorted to just, basically budgeting in fines and accepting as a tax until they can properly figure out how to deal with it. Once we decided what to do with a certain risk, we're implementing appropriate security controls. And then, of course, without monitoring if this implementation is actually working and if the risk is actually being mitigated, we cannot really talk about having properly dealt with the risk. So I know that feels very high level and very wishy-washy, but I feel that when we're talking about low-level Kubernetes decisions, I often feel that people are getting stuck in here. So for example, just a few weeks ago, I had a discussion with some people like, should you allow your developers to access secrets, or should you disable that? They can kind of log secrets anyway, or should you allow containers to be running as root? But then if you don't allow them to run as root, then you cannot use any Helm charts out there. And this boils down to, what are the risks? Do you accept those risks, or do you prefer to avoid them at any cost? It might be that, for example, for a front-facing application, that risk is just unacceptable. However, for a back office application where maybe you know the people that are using that application and you probably have already done a background check on them, maybe certain risks are more acceptable. So that's why I really want everybody to really think about this framework whenever they're deciding on how to configure their Kubernetes cluster. Okay, let me then talk about the Kubernetes attack vectors. So before I start enumerating them, let's talk about the larger context. So although, of course, this presentation is very much focused on Kubernetes, there are certain assumptions when we're speaking about Kubernetes hardening solutions. First of all, we're assuming that the underlying infrastructure is already sufficiently hardened, right? There's no point in having discussions about where to store secrets or how to encrypt secrets or how to protect them if everybody can just SSH in the Kubernetes master and retrieve them from there. Also, you generally although you want to secure Kubernetes as much as possible, but you still want it to be more like a defense in depth mechanism, and you don't want to make it, for example, um, resilient to malicious developers inside your organizations, or you don't want to make it resistant to malicious application behavior. So training your users in order to be well security minded and making sure that the application is secure or a prerequisite, and then hardening Kubernetes kind of adds another layer of security on top of that. And then we're also assuming that we have some kind of tamper-proof logging and backup environment, which is completely separate for the Kubernetes cluster. And this is extremely important because the first step in preventing a certain risk is to identify it. So, for example, am I being under attack? Is my cluster exposing secrets and so on? Are users maybe logging too much? And you really have to make sure that an attack cannot tamper with your logs. So my definition of tamper-proof, and I think this corroborates pretty well with everybody else's out there, is that whoever gains access to your Kubernetes cluster should not be. What are then the attack vectors of Kubernetes? And here I would like to, I'm not sponsored or affiliated in any way. I'm just a really big fan of the book Kubernetes Security by Liz Rice and Michael Hausenblas. And they basically wrote a whole book. It's not super thick, but still it's a whole book, talking about all the attack vectors related to Kubernetes. So for example, things like accessing the machine and VMs, accessing the etcd database, and so on. And they even describe in very big details on how to mitigate all of these attacks. So if you are, for example, working in the InfoSec department of your organization and you're working with Kubernetes, I can highly recommend you to buy this book and to look through it. And there's even an associate tutorial to make you know more knowledgeable about it. So my presentation is essentially, I would say, giving you quite a lot of information from this book, but you can also see it as complementing and highlighting certain things that are not in that particular book. So yeah, consider this though a bit of an overview to just give you a taste. So let me now discuss about how to do security hardening for each of the attack vectors. So it might come a bit like a surprise to you that we need to harden Kubernetes to begin with. I mean, why can't we just have Kubernetes secure by default so that we don't need to have this presentation and the previous book at all? And this has proven to be a little bit of a tricky endeavor because Kubernetes at the beginning needed to prove itself as being something that improves development speed. So it really needed to give that wow effect, that it just works, that you can deploy fast, that your rolling upgrades work, that your load balancers are properly configured. And this means, of course, that they started with some defaults that are more relaxed to really make sure that that wow effect is there, which of course, unfortunately means that it's not very secure by default. And furthermore, Kubernetes is also a laser-focused project. It has only certain responsibilities. So for example, it doesn't deal with topics such as intrusion detection or vulnerability scanning, and instead it allows these responsibilities to fall on the shoulder of other cloud-native projects. So to sum up, Kubernetes is not secure by default, nor by itself. And that's why you should continue watching this presentation. So let me now go over what are, in my opinion, the biggest gaps in the default security configuration, and down to writing YAML, how to bridge these gaps. So the first thing that I would really suggest you is to enable Kubernetes audit logs and application logs. So application logs are generally being captured by something like FluentD, which is then configured as a daemon set to run on worker nodes. And then they forward these logs to some kind of log storage to the tamper-proof logging environment. And there, I'm a big fan of Elasticsearch and Kibana for, let's say, hot logging entrance. And then maybe you also want to use some kind of cold logging via object storage or things like that. In case, for example, you're regulated by HIPAA, then you kind of need to store logs for approximately 6 years. And I can guarantee you, I don't think anybody managed to scale Elasticsearch to the point where it can retain data for 6 years. So then pushing the data, let's say the last 7 years to Elasticsearch, and then keeping data for 6 years into an object storage such as S3 is a perfect balance to have the best of both worlds. And then Kubernetes has a so-called audit log itself, so which pretty much means that it allows you to understand each and every API call that has been done against Kubernetes. When has a pod been created? When has a deployment been created or deleted and things like that? And if you're using kubeadm, you pretty much what you're doing is that you're configuring the API server with audit policy file, so as extra arguments, and audit log path. And afterwards, you're configuring fluentd on the master node to catch these files and to forward them to your tamper-proof logging environment. And then basically what you're getting is a bit like what I have shown in the lower side of this slide, where it basically says that this particular user has been trying to do a certain operation. So in this case, for example, I'm not sure if you see my cursor, but the verb itself is list. So I have tried to list a certain resource. That resource in particular is pods in the namespace kubepublic. And this operation was allowed because apparently I have some kind of cluster role binding called demo cluster viewer, and that allowed me to perform this operation. Now, if you only do that, unfortunately, you won't really get the full benefits of Kubernetes audit logging. So in this particular log, you see that I'm actually identified by my email address that I have done this operation, but this is also something that doesn't come by default with Kubernetes. Most of the time, what I have seen is that people are just taking the cluster admin token or key and then sharing them among several developers and a CI/CD environment. And then, of course, you are confusing who exactly did this particular operation. So it's equally important not only to enable audit logs, but also to come up with a way of identifying the individual that or the system that has performed that operation against the Kubernetes API. And this can be obtained quite nicely with a project which is called DEX. So which is pretty much an OpenID bridge, if you want, to your OpenID Connect or SAML provider. So the way this generally works is that you already have within your organization some kind of identity provider, such as G Suite or Active Directory, and then you're trying to reuse this one in order to give people access or to deny them access to the Kubernetes cluster. And this is also very nicely, if you have a compliance department, you can also tell them then a very nice story that if a person leaves the organization or if a person moves department, then their authorization needs to be changed only one place, and that kind of revokes their access in all kind of different places, as opposed to having to manually check if this person needs to be erased from the Kubernetes username and password static database or needs to be removed from this system and that system and so on. And again, if you're using kubeadmin, you have basically 4 parameters you need to specify here: the issuer URL, the client ID. So this is some OpenID terminology to say how exactly your Kubernetes cluster authenticates to DEX itself. And then you pretty much specify in the JW token that is returned by DEX where exactly is the username stored and where exactly is the groups that the user belongs to stored. So this basically allows you to tune what exactly is the username from Kubernetes perspective. Is it the email address of that user? Is it maybe a unique identifier for that user? Is it maybe their display name? And so on. And then once you have configured this, you can then use on the client side the Kubernetes OpenID connector. And what happens is that if you type something like kubecontrol get namespace, then a browser window is being opened. And then you can pretty much say, well, I want to log in with DEX, and then I want to log in with my organization-wide authenticated provider. The OAuth dance or OpenID dance is then being completed, and you're being given a very short-lived credential that allows you to then comfortably communicate with your Kubernetes cluster, while at the same time being identified for the operations you're doing. Okay, so far we have good logging. We can identify users individually, but we kind of also want to restrict what those users are allowed to do, right? And this is again a typical InfoSec discussion. Like we still want to not hamper the productivity of people. We still want them to enable them as much as possible to see how their code is being run in production, but at the same time we don't want to allow them to do everything. And for this, the role-based access control mechanism can be used. So for example, you define a cluster role that is called view only, and this allows people to get, watch, or list daemon sets, deployment stateful sets. I would suggest you not to allow, for example, to list secrets, but not to get them. And this way, for example, it's very easy to avoid misconfiguration because your developers know exactly what is the name of the secrets. But on the other hand, it also ensures that they cannot just carelessly extract those secrets in case they do some kind of mistake. And then via a role binding, you're actually saying who is allowed to do these particular operations. And if you're using DEX, as I shown before, then actually the name is pretty much sorry, so you can use either kind user, and then the name is pretty much the email address, as I have discussed previously, or otherwise you can give group-wide authorization, and then again, what definition from your identity provider, how you're defining username and groups from your identity provider to Kubernetes determines what exactly is the string that you need to type here. And I would suggest you to have roles such as, for example, allow to view everything except the secrets, or allow to view everything but not to the right. Maybe you can also have a role such as allow all operations except to fiddle with network policies, because some organization likes to have a different department within the organization that creates network policies, and a different department that deploys the code. I'm going to talk about network policies a bit more later. I also want to highlight now the importance of being careful, because it's not only humans that access the Kubernetes API, but it's also machines that access Kubernetes API. And in particular, basically all the pods that are running inside the Kubernetes cluster are allowed or have the potential to access the Kubernetes API of the same cluster. And they do this via so-called service accounts. And what I suggest you is that if you don't need them, if there is absolutely no good reason for a pod to access the Kubernetes API, just use this YAML command here, automount service account token to false, and maybe also create a service account, a default service account that is very restricted. And this way, or you can also disable this per pod. And in that case, basically, there is absolutely no way for this pod to do any kind of operation against the Kubernetes API. So, which of course also means that in case this pod gets compromised, then the attack surface is a lot smaller, since they cannot then talk to the Kubernetes API. In case role-based access control proves insufficient for your own needs, there is this project called Open Policy Agent, which is pretty much like a firewall for your Kubernetes API. And it allows you, basically takes as input the API request, and it outputs, yes, this operation is allowed, or no, this operation is not allowed. And you can do all kind of fun things with this. For example, you can configure that only trusted repositories are allowed to be pulled from. So for example, you can say that, well, we're having this private Harbor Docker registry that we are carefully managing. And if you're pulling for anything else, like for example, Docker Hub or I don't know, Quay, or some kind of other third-party registry that you have not carefully checked, then basically a pod won't start because the pull action is just denied. And similarly, you can, for example, enforce that network policies. Again, I'm going to talk about, I'm building here tension around network policies, right? So you can, for example, enforce that every single pod needs to be selected by network policies in order to make sure that, they're properly protected. You can also do other things like this. For example, some sanity checks, like make sure that the ingresses have the right domain name so that typos are not preventing the application from coming up, and so on. So like I said, it's a very flexible language that acts like a firewall for the Kubernetes API. Okay. Of course, it is nice to assume that the application is written securely and that you don't need to worry about it becoming vulnerable. But of course, when we're talking about security hardening, we're kind of assuming that the attacker may potentially gain access, control of an application. And then what we try to do is to reduce as much as possible the associated blast radius, so the damage that such an attacker can do. And what are the risks if an attacker gains access of a pod? Well, like I said, each pod has access to Kubernetes API by default, so they can potentially access the Kubernetes API and then run a more privileged pod. We have talked already about how to restrict this in the previous part of my presentation. They can potentially try to escape to the host, but they can also potentially move laterally. So for example, to check what other pods in the system are vulnerable, or is there maybe a database pod to which I can use some random username and password to get access to. And in order to mitigate these risks, people suggest to use pod security policies. So this is basically something that tells you what exactly is a pod allowed to do within a certain namespace. And for example, you can, for example, say that you don't want it in a specific Kubernetes namespace to run privileged pods. If your pod is privileged, then pretty much it can escape its containerization and just get access to the host file system or the host PID table and so on. You can also make it drop all capabilities. So for example, there was a recent kernel vulnerability just a few months ago, if I'm not mistaken. And what this basically meant is that if you had the capnet raw capability to your pod, then you could pretty much do everything you wanted with that specific host. But of course, if you were using pod security policies and dropped all the capabilities, then you basically didn't have to worry about this vulnerability and could just, upgrade the Kubernetes cluster whenever it was suiting you and not the attackers. Another way of escaping the pod is via volumes. So for example, you can mount a host path, and then via that host path, try to reconfigure the host so as to enable an attack. And in order to mitigate those risks, pod security policies allow you to configure only a whitelisted number of volumes that pods are allowed to mount. So for example, here we're allowing to mount a config map, we're allowing to mount an empty directory, we're allowing to mount secrets, but very importantly, we're not allowed to mount host path or anything like that. And then the other commands here are just regular stuff that one does in order to make sure that this pod doesn't have access to the host network or the host IPC namespace or the host PID table. I should here just caution you, there is now ongoing, so as you might notice, the pod security policy API is still in beta, and there are quite intense discussions nowadays on whether this API should be kept or whether one should rather refer people to Open Policy Agent in order to achieve the equivalent effect of pod security policies. But for now, I find that pod security policy is very clear and it's very easy to follow what is intention. It's very easy to configure. So as long as it exists, I suggest you to stick to it. Okay, let us now talk about network policies. So let's assume that an attacker has gained access to a pod. The first thing they're going to try to do is to move laterally to see what other pods they can get access to. Is there maybe a database pod that is not sufficiently protected? Is there maybe a Redis key value store that is by default assuming a trusted network, and so on? Can I, for example, send spam for that pod, or maybe mount a DDoS attack against an unknown victim from that particular pod? And in order to mitigate this risk, Kubernetes implements network, or let me put like that, Kubernetes defines network policies that needs to be implemented by some kind of container network provider. The one that I prefer is Project Calico, but there are also other ones that implement network policies. And then if you, for example, want to deny egress network traffic, so you're not allowing any pod by default to communicate to anybody nor to the internet, then basically just writing this YAML code, and which selects all of the pods in the cluster, and then you basically say, well, I want an egress policy, and then since everything else is blank, basically there is nothing that is allowed. Or you might want to do some finer tuning. So for example, you want to say that, well, you can access the database from the backend, but not for example, from the message queue or from the front end. And then you would write something like this so that the network policies applies to those pods that have the label role equal to database, and then allow ingress traffic from the pods whose role matches, whose label called role matches backend. And this is a very nice mechanism to have fine-grained control over who can talk to whom inside the cluster, and also who is allowed to talk to things outside the cluster. By default, you don't really need to have a network policy, and if your pod is not selected by any network policy, then it's an allow all. So that's why, as I advertised previously, it's pretty useful to have an open policy agent policy that makes sure that the pod needs to be selected by some network policy, and yeah, to make a mindful decision about what exactly that pod needs to talk to. Okay, I also very strongly suggest to invest in intrusion detection. So basically, to know if something fishy is happening inside a cluster, you should get some kind of warning or alert, or there should be some traces left behind so as to allow you to evaluate the impact of the attack. And to this end, I suggest you the project Falco, which basically monitors all the system calls. So this is the lowest level API between user space and the Linux kernel. And it does this via a pretty new and exciting technology called eBPF, which is on one hand very fast and also very efficient. And the thing is that it basically detects and logs suspicious activity, and these logs can then be forwarded to your tamper-proof logging environment. And what you would be getting is a graph that looks, for example, like this. So this, for example, shows me that during this time, there were a few attempts to do outbound SSH connections, and there were also a few attempts to connect via SSH to pods. So if you're having some kind of pod that tries to connect to the outside world via SSH, that's a pretty suspicious activity. That probably means that somebody has gained access of a pod and is trying to use it as a platform for an attack against another victim. And even though network policies might block this attack, it's still good to know about this suspicious activity and be able to investigate what is going on and why exactly this is happening. And then, of course, preventing is better than a cure. So all of these techniques, of course, they reduce the damage that an application can do in case it is compromised. However, it's also very important to integrate this with container image vulnerability scanning. So to prevent that the application is vulnerable to known vulnerabilities. And to this end, I strongly suggest the open source project Trivi, which is a container vulnerability scanner, and it can be integrated in several ways with Kubernetes. So one of them is that you're using the Starboard project that you can, for example, run daily on the Kubernetes cluster, and then it produces a report of, I looked at all the images that are running in production, and these are the vulnerabilities that I found with this level of criticality. The other option is to run a container registry such as Harbor, which integrates very well with Trivi. And that one, for example, could block pulls from itself in case a vulnerability has been detected and in case the criticality is above a certain threshold. And then, of course, there are also very many commercial offerings for vulnerability scanning. Here, the ones that I'm most familiar with is Snake and White Source. Now, of course, hardening is a never-ending story. So this is why I had the InfoSec discussion at the very beginning, because you still have to be mindful about what are the risks you're trying to protect yourself against and how much do you want to avoid those risks. And there are quite a lot of tools such as KubeHunter, Polaris, or KubeBench that are giving you very detailed reports of what is the security posture of your Kubernetes cluster. So, for example, if you're running against a vanilla Kubernetes cluster, KubeBench might issue you a warning, such as that protect kernel defaults the argument protect kernel defaults is not set to true to the kubelet, and if you set this argument to true, then it would pretty much protect the system calls from being tampered with, which is considered that it's producing a way more secure Kubernetes cluster. I'm not going to go into very many details because these tools just produce tons of recommendations. So my suggestion is just to potentially run these tools once over your cluster, just to see approximately, get the feeling of how far you are from the ideal, and then maybe just take issues one by one and decide if they're worth hardening or if it's just too much hassle for your current risk profile. Okay, I hope I managed to convince so far that yeah, making a Kubernetes cluster secure is quite a lot of work, and it's quite difficult to get it. And sorry, although it's not difficult, but it still requires quite a lot of diligence and care in order to get it right. And this is why we have launched as open source the compliant Kubernetes distribution, which essentially comes with all of these projects, the best in breed projects for each of these security related controls, and also with best practice configuration already packed in so that you do not have to start from scratch. And I just issue here some of the logos that you might find from the previous slides, but of course it also comes with a good observability stack and also with making sure that the lifecycle of the cluster are properly being configured. And as I advertised previously, so it comes actually with 2 Kubernetes clusters, one to run workloads and a minimum number of pods just to make sure that logs and observability is forwarded. And then all of the other tools are actually being executed in a second cluster, which acts as a tamper-proof environment, but all standardized on top of Kubernetes. And we have it available as a managed service in case you don't want to have a headache. But of course, you are also free to run it as an open source project. And in which case, we also very much like to see what is your experience with it, and how well it reduces your compliance burden. And maybe you can even contribute and security harden even more than we managed to. So to sum up, GDPR is implying a strict handling of personal information. And among others, it enforces security by design and by default. And it also requires you to do proper breach reporting, both to your customers, but also to the relevant authorities. And we have been talking about Kubernetes hardening, in particular how to protect the Kubernetes API, but also how to restrict application permission to reduce the blast radius. And we have been also talking about vulnerability scanning. And finally, I have shown that there are quite a lot of things that are necessary to make Kubernetes secure, and which is why I have also briefly talked about compliant Kubernetes, which tries to make it as easy as possible to be secure and compliant while at the same time running at the speed of Kubernetes. And here is the URL. I strongly suggest you to check it out. And in case you are going to take part in KubeCon North America Virtual, where they're also going to have a sponsor booth in which we can either make your demo or maybe discuss more. I mean, of course, we have now a question and answer part, but maybe by that time you'll have more questions, or maybe you have found more problems, and then you can also come and ask us. Yeah, thank you very much for your attention. I'm ready to take questions now.